Nutrition advice has become a bit of a circus. Coffee is good, coffee is bad, low fat works, low fat doesn't work, low carb works, and somehow everybody has the answer. But what if the real question wasn't what diet works? What if the real question is what works for this person? Today, we are talking about personalized nutrition, the science of nutrigenomics, and how our genes may help explain why the same food, supplement, or caffeine habit can help one person and completely backfire on another. Welcome to the True Wellness Podcast with Dr. Z, where we explore what it takes to live with vitality, balance, and purpose. I am Dr. Z, and each week I will bring you powerful tools, inspiring stories, and expert insights to help you thrive in every area of your life. From health and wellness to mindset and navigating life's challenges, this podcast is your guide to creating a life of true well-being. Be sure to check the show notes and grab your copy of the True Wellness Checklist so you can get started on your journey right away. Now, let's get started. Welcome back to True Wellness with Dr. D. I'm your host, Dr. Danielle Zanzarov, and this is a conversation I've been really looking forward to because so many people are doing all the right things on paper. They're eating clean, they're taking supplements, they're following generic wellness advice and still not getting the results that they want. And one of the biggest reasons may be this: nutrition is not one size fits all. And there is growing interest in using genetics to actually begin to make nutrition recommendations more precise, more personal, and more clinically useful. So Nutrigenomix describes its work as evidence-based, personalized nutrition built around actionable genetic information, which is interpreted with a healthcare professional rather than just kind of a standalone diagnostics tool. So today's guest is Dr. Ahmed El-Sohemy, professor of Nutritional Sciences at the University of Toronto and the founder of Nutrigenomix, Inc. His research really focuses on identifying genetic markers that predict how different people respond to dietary factors. And according to his bio, he's published over 200, that's a lot of peer-reviewed papers, over 200 peer-reviewed papers, and delivered more than 400 individual talks around the world. So we are grateful to have you here today and all of your wisdom and the guidance that you're going to provide our community with. So thanks for being here.
Thank you for having me. Excited to have this conversation.
Excellent. Okay. So for our listeners who are brand new to the topic itself, what is nutrigenomics in plain English?
Sure. Well, as you can probably gather by the word nutrigenomics, it really is a branch of science that deals with the interface between nutrition and our genetic makeup. And the ultimate goal is really trying to figure out how we can use genetics to understand why some people respond differently from others to the same foods, beverages, and supplements that they consume.
So what I hear you saying is we're not all exactly the same. So all of the genetic makeup that we have can actually impact the way that we react to things differently as human beings. So just because I'm a human and you're a human doesn't mean that we both respond to, say, gluten or dairy or coffee or a specific vitamin in the same way. Is that the gist of it?
Absolutely. And I'm sure everyone can think of someone that they know that, cannot handle something in terms of their diet. You mentioned dairy, lactose intolerance, right? Of course, some people can drink a glass of milk and have no problems whatsoever. Others, because of an alteration in the sequence of a gene, they're not able to make enough of the enzyme lactase that breaks down lactose, and they experience stomach problems, diarrhea, gas, bloating when they consume milk. The same, of course, applies to gluten. And when you think of those who have the most severe form of gluten intolerance, celiac disease, that is impacted by a specific gene, the HLA gene, that predisposes some people to celiac disease. And for them, they have to absolutely limit, in a very strict manner, gluten from their diet. Now, those are a couple of examples where people pretty much feel the effects kind of shortly after consuming those components of the diet. But when it comes to other things like, how much vitamin C you're consuming, how do you know how that affects your heart health? You don't actually feel it, but research shows when we track people who have high or low intakes of vitamin C and we track them over years, and then we measure things like, hypertension, heart attack, cardiovascular disease, we see that those genetic factors that affect the metabolism of those vitamins or minerals impacts their risk of developing those diseases. So the short answer, of course, is, as you pointed out, one size does not fit all. We give generalized recommendations to everybody, but it works for some people and doesn't work for others. I think you mentioned coffee as well. How many times do we hear that a study comes out saying coffee is good for us? Another day, study says coffee is bad, and another day, coffee doesn't do anything. Well, there's a reason for those inconsistencies, and it's because these studies that are generally well designed are done in individuals who are genetically different. They're done in different populations. And so one of our, kind of landmark studies that we published just over 20 years ago now in JAMA showed that coffee can be either good or bad for you depending on this specific gene that affects your ability to break down and eliminate caffeine from your system. So that's kind of an example that illustrates this concept that, we can't just tell someone how much or what to consume without knowing their genetics.
I think that's pretty powerful, and it helps people sort of solve that mystery when they feel like they're stuck in between, like, well, how come that's working for so and so and not working for me, right? How come I can't lose weight and I'm doing the same thing that that person is doing? So, I'm curious. Tell me a little bit about, how did you first become interested in the relationship between genes and food and health, and how did that all come together?
Well, that actually started by chance. And when I was a graduate student working on an experiment in mice and rats, I conducted a study looking at the role of cholesterol metabolism in breast and colon cancer using animal models. And the results of my experiment, the first experiment, were the complete opposite as what another research group found. And I thought, I must have made a mistake, right? I mixed up the diets or I mixed up the animals or something. But we were able to confirm that there was no mistake. And everything between those experiments were the same, except for the strain of rat or the strain of mouse that was used. So a strain is like, a breed of animal or basically genetically different, right? And so you have white mice and black mice and brown mice and different genetic backgrounds. And we were able to confirm that, sure enough, cholesterol has the complete opposite effects on two different kinds of mice. And so at the time, I thought, well, if two mice can respond differently to the same diet, then surely two humans can respond differently. And we knew, of course, that nutritional sciences has been plagued with inconsistencies and these conflicting findings, which unfortunately has given our field a bit of a bad reputation. Right? People say, well, you guys don't know what you're talking about. First, you tell us fat is bad. Then you tell us carbs are bad. And then you tell us coffee is good. And then coffee is bad. And so it's unfortunate that we've had those inconsistencies. But now that we realize they're not really that inconsistent, if you look at them properly and you conduct a study that you're looking at the right genetic subset, you should get the same result consistently and reproducibly. And that is what we're seeing now. And so that was around the turn of the millennium. just before the first draft sequence of the Human Genome Project was published. And I decided to shift the focus of my research to look at genetic differences in humans and to try to see if this could explain some of the inconsistencies that we're seeing with just about any dietary factor and any health outcome. But we started off coffee and heart disease, and since then expanded that.
So tell us a little bit about what you learned about coffee and heart disease. I know you touched on coffee and we touched on
Yeah.
we touched on lactose a little bit, but can you dive a little
Mhm.
bit further into that?
Sure, yeah. So, again, there's a gene called STIP1A2 that metabolizes caffeine, and roughly half the population have a version that we would call slow acting, and we would call them slow metabolizers of caffeine specifically. And interestingly, you can't feel if you're a fast or slow metabolizer based on how caffeine makes you feel, right? Because some people say, oh, if I'm definitely a slow metabolizer because if I have a cup of coffee after 1 in the afternoon, it keeps me up all night. Well, it doesn't mean you're a slow metabolizer. It means you have a different gene that affects the stimulating effects of caffeine. Doesn't have anything to do with whether or not coffee is good for you or bad for you. And that's important to note because sometimes people say, well, just, based on how your body feels, just kind of go with that. Well, that is not what determines whether something is actually good for you or bad for you, right? I mean, a complete contradiction of that is broccoli. Some people just can't stand the taste of broccoli, but is generally good for them, right? You can't say, oh, well, I don't like the taste of it, so, I should stay away from it. That's not the case. So you have to rely on scientific evidence. And so we showed that in that 50% of the population that are slow metabolizers, coffee increases the risk of a heart attack. But among the fast metabolizers, it had the opposite effect. Moderate consumption actually lowered their risk of a heart attack. So it's not even just that, oh, it increases your risk or it doesn't do anything. It could actually be beneficial in some individuals. And since then, other research groups have replicated this, looking at different outcomes: prediabetes, hypertension, kidney disease, all showing the same thing. That if you're part of that 50% of the population that's a slow metabolizer, coffee is going to increase your risk of those conditions, and you need to limit your intake of coffee and caffeine.
That is such useful information because I think, I remember I used to teach over at Hofstra, and I always had my students pick some sort of topic that was this, embattled topic that everybody was debating and get to the root of it. And, students always inevitably chose coffee as one of those topics to begin to research. And they'd always come out with, well, they obviously didn't see your research, right? Because they said, well, these people said it's good. These people say it's bad. And they're like, well, the jury's still out. And so it's interesting because that same exact thing could have a different response in somebody's body, but based on their specific body composition. And, I'm always a big proponent of there is no one size fits all. And, I'm thankful to have a relationship with you and Nutrigenomix. And many of our clients have done the Nutrigenomix testing, and it's fascinating. They're always, shocked and surprised, like, oh my gosh, like this verifies. Or sometimes they'll be like, well, Dr. Z, I know you said to stay away from the gluten, but now I really understand that I have to stay away from, gluten or XYZ or whatever, because they have the validation and the verification of it. So beyond coffee, what would you say are some of the more intriguing results that you've found through your research that, you know, might have people say like, okay, maybe I need to go get some of my genetics tested here. And for all of you who
Mhm.
are listening, we'll have a link in the show notes. You can get the test, the Nutrigenomics test. I've seen, as a functional medicine practitioner, it's like the wild, wild west and lab testing everywhere. And I love the Nutrigenomics test because the report of findings is just so crystal clear and easy to understand. It is like a manual, right? But it's in English. Whereas other companies, I look at some of their tests and they're like this is not useful necessarily to the lay person. And so that's one of the wonderful things about
Mhm.
your tests. So kudos to you. But what are some of those other like ahas that you've come across in the years that have been like a real game changer?
Sure. Well, first of all, thank you for the kind words about the Nutrigenomics report. And I can tell you that we did go to, extreme lengths to make sure that the science was translated in an easy to understand manner. You can complicate things or you can simplify things. And the important thing is to make sure that the message is communicated effectively, reliably, and respecting the science. So again, I think that's something that we collaborated with those who are experts in scientific communication, and it's important to make sure that people understand what do we do with this kind of information. So thanks again. In terms of the research that we have done, we've done a number of studies on all kinds of other aspects of the diet. So when we think about some of the micronutrients like vitamins and minerals, vitamin C, iron, vitamin D, there are genes that affect the metabolism of those nutrients, and those nutrients have been linked to different health outcomes and performance outcomes. We've done some research on athletic performance and genes that affect iron metabolism, genes that affect caffeine metabolism, because we know caffeine is also used as an ergogenic aid by a lot of athletes. It helps some, it doesn't for others. And in fact, it hinders performance in some. And again, that is related to the fast and slow metabolizers of caffeine. When it comes to the micronutrients, we have a big research program in women's health and looking at specifically premenstrual symptoms that impacts the quality of life for millions of women, but is an under-researched area of investigation. And it turns out that having suboptimal levels of certain micronutrients like iron or vitamin D and vitamin C, that increases the risk of certain premenstrual symptoms. And we've layered in on top of that the genetic differences. And so one example is a paper we published just last year in the British Journal of Nutrition, looks at folate and premenstrual depression, specifically premenstrual depression. And some women experience severe mood swings and anxiety and depression during that time of their cycle. And it turns out that this gene that's involved in folate metabolism, MTHFR gene, that's widely studied for a lot of health conditions, that the um, the low acting version of this gene was associated with a significantly greater risk of premenstrual depression, but only in women who had lower levels of folate in their diet. When they consumed higher amounts of folate, the effect of the gene was completely abolished. Meaning a few things. One, that genes are not our destiny. And two, that even if you have these genetic vulnerabilities, that it's actionable. There's something you can do to mitigate that increased risk. And in this particular case with premenstrual depression, it was ensuring that you had optimal levels of folate in your diet, and that completely abolished any adverse effect of having this genetic variant.
You like said the golden word, like the golden symbol, the golden letters, MTHFR. So I know MTHFR gets thrown around a lot. We also know that it impacts a lot of the population. Can you talk to us a little bit about what is it? How does it impact people? What should they be looking out for? I'll let you dive down the rabbit hole of MTHFR.
Sure. Well, to be honest, I would rather not, but I will address it because M- MTHFR is one of those I can't describe it any other way than to say an overhyped gene, an enzyme. Obviously, it's very important for biology and the metabolism of folate, and folate itself plays a number of critical roles in the body, but it's not the be all end all. And I know there have been books written entirely on this one enzyme in this gene that codes for it, and it's been linked to autism and Alzheimer's and every condition under the sun. And that's because folate does play an important role. However, it's just one of many, and it really relates to folate metabolism specifically. So, if you have this version of this gene so it exists in two different forms, and as we know, we inherit one copy of most genes from our mother and one from our father. So we can have roughly 40% of the population or 30% have one of these versions that decreases activity of that enzyme, and an additional 10 or 15% have two versions of that, and they have even lower enzyme activity, and they need they need the most amount of folate supplementation. And so, yeah, I think if you focus on your diet and making sure that you're getting adequate amounts of, green leafy vegetables, and there's a lot of grains that are fortified with folate, and you're getting adequate amounts, then you don't really have much to worry about. The gene itself is not the cause of autism. It's not even the biggest contributor to that. Although again, there have been some popular books written about that. And I'm always amazed because, we hear from the company Nutrigenomix, we get people that email us and say, "Oh, do you test for MTHFR?" And it's just puzzling. Why would anyone from the public just out of the blue say they just want to test for that one gene?
Popularity. It's social media popularity, right? It's like
Right.
whatever the
Right.
buzz or the trend is, and everybody's
Yeah.
seeing in their Instagram and their TikTok
Yeah.
scroll. That's why it's
Yeah.
there, right? What the next influencer is talking about.
Right, right. And right up there with methylation because it does contribute to methylation. But again, a lot of people don't realize that methylation is a double edged sword. It's not like we all need more methylation or less methylation. It's all gene specific, and methylation, impacts the turning on and off of various genes. Some genes you want to turn off, others you want to turn on. And so because folate contributes to methylation, again, you get, these people that are, talking about it on TikTok. Oh, you got to get a methylation test so you got to measure MTHFR. Well, it is a good idea to measure your MTHFR to understand your folate requirements. But, don't get lured into buzzwords like methylation when, for all intents and purposes, it doesn't really mean anything from a practical standpoint. These are things that impact molecular mechanisms of action that we do in a lab in terms of testing how folate impacts health outcomes. It's not something that you can actually measure directly and give any kind of guidance on that. But anyhow, all that's to say, MTHFR, it is one of the genes that's in the Nutrigenomics report. And for those who are interested, yeah, you can get tested and find out how that impacts your folate recommendations.
I love this conversation because here's what I'm hearing, and I'm hoping all of our listeners are hearing, and it's something that I say all the time, right? There is no one specific thing that makes or breaks your entire health and your lifespan and all of that. It is a combination of a lot of different things. And I had a client who messaged me. We were having a text conversation about her diet and stuff. And she's like, come on, do vegetables really make that much of a difference? Like, does my diet really make that much of a difference? And I'm like, here's the magic sauce, right? Like, we can correct 80%, maybe more of everything if we just hone in on the diet, if we just make those dietary changes. And I hear you echoing that. Did I catch that correctly?
Yeah, yeah, absolutely. And yeah, what works for one person might not work for somebody else. And you can try different things using trial and error, or you can figure out what your genetics is telling you and take some of the guesswork out. Now, I just want to be clear that the a genetic test is not a cure for anything, and it's not the be all end all. But it really is understanding your unique biology. I give the lactose intolerance example as one that I think a lot of people can relate to. Imagine someone just, constantly has stomach pains and issues and diarrhea and bloating, and they have no clue, right? They're eating, they're following, healthy eating guidelines that recommend consumption of dairy products, and they just don't think that that component of their diet could be what's contributing to that. Um, I had a friend who was, telling me about, some bloating issues and stuff, and I was, just asking about their diet, and they mentioned yogurt a few times. And I'm like, well, what kind of yogurt, right? Because there are some kinds of yogurt that are lactose free or very low in lactose. It was just regular yogurt that actually does contain a good amount of lactose. And I suggested, just try cutting that out and within a few days, they said, wow, I can't believe it. It was like, you know, and, we didn't have to test them genetically because that's something that you can find out pretty quickly, right? So for some things like lactose, just try removing it and see what happens. But for other things like, folate, vitamin C, different aspects of the diet, it will take a much longer period of time to understand if altering your intake actually had an effect, right? I mean, sodium and blood pressure, we tell everybody cut back on sodium. Not everybody needs to, and certainly not to the same extent. And so if you're looking to see how sodium affects your blood pressure and risk of hypertension, that can take, quite a bit of time. You're not going to see that right away. But before you even embark on that path, look at your genetics and say, well, do I even need to? And if it shows that you don't, well, then, you're like, okay, I'm lucky. I don't have to worry about this as much. Doesn't mean you go to town and, eat bags of potato chips and all kinds of salty foods, but you don't have to worry as much about sodium. Maybe you need to be more concerned about saturated fat intake because that will increase your risk of obesity because you have a particular gene, ApoA2, that does greatly increase your risk of obesity with increasing consumption of saturated fat.
Yeah, I love that. And here's the thing that comes up all the time, right? The thing that's great about a test like Nutrigenomics is you only have to take it once. It's not like a blood test that it's going to change all the time. Like your genes are your genes, and those are your genes.
Exactly. And this is where sometimes, you see other kinds of tests like microbiome testing, and this is like a whole other topic. The microbiome is very fascinating, and we're learning more and more about it every day. But the microbiome changes not only day to day, but even within a day. And so it helps us understand because the microbiome does affect metabolism and does affect your health. But there are these companies that are, claiming to give you dietary recommendations based on your current microbiome. And the science is just not there because it's constantly changing, right? And oftentimes, and this is usually a red flag, if they're trying to sell you a supplement or a shake or a potion or something based on a microbiome test, that's something that, again, is not rooted in evidence. Whereas, as you point out, your genes are your genes. You're born with them, you die with them. And they're not going to change. And so it is at least kind of a one-time test based on the current number of genetic markers that we have in the panel.
Yeah, I love that. There's so much today is just kind of driven by marketing and in the functional medicine space there's thousands of different tests and you look at these tests and you're like, okay, well, what is the efficacy of this test? Like you're right, like that your microbiome is going to change all the time as that the interventions that we do because I have clients. I'm a little test conservative in my practice. I know
Mhm,
some functional medicine practitioners are like, you're going to spend $10,000 in tests before we do anything, and I'm like, it doesn't work that way because I already know we're going to have so much change in a short period of time. Like let's get some of that out of the way. Let's
mhm.
actually see what's underneath all the other stuff that's happening rather than spending $10,000 for that. Um, but so I'm right on the same page with you there. What would you say to practitioners who are listening? How should practitioners think about genetics kind of in that bigger picture? Like how does the genetics fit alongside symptoms and labs and lifestyle and environment and behavior?
Well, I think for any, especially any practitioner that gives nutrition advice, which I would imagine just about every practitioner should, right? If you have a patient that has any health condition whatsoever, nutrition affects everything. There is not a single condition on the planet that is not impacted by your nutrition. Nutrients impact cellular health. That can be a brain cell, a muscle cell, a liver cell, any kind of cell, and that affects the functioning of your body in some way or other. Now, genetics, for some, they might view that as, a bit intimidating if they didn't really study it. But as you know, because you've seen the reports, they're not that complex. We've distilled that information. And, looking at caffeine genetics, for example, you're either a fast metabolizer or a slow metabolizer. You don't have to understand the molecular sequence or the genetic architecture of that particular gene. You just need to know, all right, I need to limit my caffeine intake because that's what the report is telling me to do. It's based on a genetic test. So, um, for some of the practitioners at first inquire about the testing and they want to know, is this something that, I can offer to my clients? And then one question they often ask us is, well, who's a good candidate for a genetic test? And my answer is, if you eat and drink and you care about your health, you're a good candidate, right? You don't have to wait until you've already developed diabetes or hypertension or high cholesterol, right? Ideally, for someone who's ostensibly healthy, you want to figure out, how can I stay that way? Am I doing the right things? Is my diet aligned to my genetics? Am I eating the right amount of protein to prevent me from gaining weight slowly over the years? Or if I'm trying to lose weight, will that help me lose weight? Talking about weight management, there's all kinds of fad diets out there, right? Low fat, low carb, keto, paleo. Uh, Many of them do consist of a high protein diet, and it turns out there's a gene for that predicts whether or not a high protein diet is going to help you. So again, you can do it by trial and error, wait several months to see if it's worked, but then if it doesn't, you might be frustrated and not pleased with yourself and thinking maybe you didn't have self control or blaming yourself for some reason or other. But if you don't have a particular version of the FTO gene, the scientific evidence suggests that a high protein diet is just not likely to work. And that's been demonstrated using randomized controlled clinical trials. So again, it's about taking some of that guesswork away and getting a huge leap in terms of understanding how your diet can be better aligned to your genetics.
That's great. Is there from your research, and we've already covered, you've got so many different publications. What are maybe the top 3 different areas that you found to be surprising or that you find to be most impactful for people?
Well, that's a tricky one because, you know, I often say when it comes to genetics is that you don't know what you don't know, right? And so some people will say, "Oh, well, I want to find out about MTHFR or I want to find out about, caffeine metabolism." And then I often say, "Well, did you ever think about choline?" And they're like, "Well, what's choline?" They've never even heard about it. And then they find out that they have a gene that makes them inefficient at metabolizing choline. And over the years, if you're not getting enough choline, that's going to impact the health of your liver, right? And people don't really realize that until their liver function reaches a critical point where you're hoping during your annual health check that your doctor is checking your liver enzymes and all of a sudden, oh, we have a problem here, right? Or vitamin D, right? Some people just think they take it for granted, but they don't realize that they might have a gene that makes them vulnerable to having low blood levels of vitamin D. So one of my favorite parts of the report is actually those micronutrient related genes, right? Vitamin C, E, D, B12, B6, because you don't know unless during your annual physical you're getting all these micronutrients measured, which nobody that I know a lot of people, nobody gets, I don't even get all of those things tested. right? I have to ask my doctor specifically for some of them just to make sure that those levels are okay. But even so, your blood levels just indicate your current nutritional status. And, if you just had a bunch of carrots over the past couple of days, your vitamin A levels are going to be fine. Right. And so, but you don't know over the course of time if you're maintaining optimal levels of each and every micronutrient. So, having this kind of test, all of those genes related to micronutrient metabolism, I would say, are critical to know. Now, there are other sections of the report like weight management. But if a person's fine with their current body weight and they're, you know, fairly active and they're, consuming a fairly well balanced diet and weight management is not an issue, that's great. You don't even have to look at that part of the report. Then there's a section on food intolerances and sensitivities, and this could also shed light. Some people have learned through our tests that they have celiac disease. And they thought, well, I've never really experienced the classic signs. When I eat pasta, I don't have diarrhea and massive stomach pains or any of that. But celiac can affect so many different systems, can even cause seizures in some people. And so it wasn't until they removed gluten from their diet that they realized, oh, hey, I used to have these kind of joint pains. I thought it was just part of getting older, but no, it was an inflammatory response caused by gluten. So again, they didn't know that gluten could be important for them. So some people might go in saying, oh, this is what I want to know. I'd say, no, you got to flip it around and say, tell me what I should want to know and what I should be concerned about. And that's what a genetic test reveals.
Yeah, the things we haven't even considered. I think there's a lot of hype in the genetics world that's happening. How do you how do you separate what's truly actionable versus what's still preliminary?
So that's a good question. I mean, there is we've tried to take a kind of a conservative approach in terms of the markers that we put in. We want to make sure that they're robust, reliable, and reproducible. And that's what we've done. When we first launched the test almost 15 years ago, we had 7 genes, just 7. And at the time, I remember some people saying, "Oh, why just 7? You got these companies offering hundreds of genetic markers." We're like, well, we know the science. There absolutely aren't hundreds of genetic markers that you can give actionable information based on reliable scientific evidence. Um, and there used to be this company that offered a test on find out if a low fat or low carb diet is best for you, not based on any published evidence, but it was gimmicky. And so that's the problem. It's a bit of a buyer beware because it's a bit of a wild west and there's no real solid regulations on the kinds of claims that can be made. But again, I'm an academic first and I have to have the scientific evidence. And if it's not there, just because someone wants a test for low fat, low carb, we're not going to give it to them. Now, as the years have gone by, there have been some studies now that have shown that certain kinds of fats, some people do benefit more based on their genetics. And that's why we added those into our panel. So we moved from having 7 genes to 13, then 45 to 70. And then we have also specialized panels now specifically for things like histamine intolerance. We're just about to release one for ApoE that impacts brain and heart health. And it's one of the most, the strongest genetic risk factor for early Alzheimer's as well as heart disease. And that gene's been around. It's been known to be an important risk factor for a long time, but we didn't add it to our panel because there was no evidence that there's something you can actually do. But now that science has grown considerably, and in fact, there are over 10 different lifestyle interventions that you can embark on to mitigate the risk associated with having that ApoE4 risk allele. And again, that's a test that we're just about to launch, I think, in just a couple of days.
That's exciting. And I really want to acknowledge you and your company for having that level of integrity because I preach a lot. I got my soapboxes. Out in the world today, people are just saying stuff. They're just throwing stuff out there. There's so much marketing. And I really appreciate that you're bringing that level to integrity. Like, hey, I'm not going to put something out just to, you know, play into the hype if there's actually not the information out there. So I thank you for that on behalf of everyone else who appreciates integrity as a place to stand in. So, can you tell us, just kind of feeding off that conversation, you know, what what can genetic testing for nutrition generally, or genuinely, I should say, genuinely tell us right now, and what can't it tell us? Like, how do people
Mhm.
differentiate between that?
Sure. Well, I'll start with what it cannot tell us. It cannot tell us that we are going to die of a heart attack or that we're going to develop diabetes or hypertension or cancer. What it can tell us is how our body processes various nutrients and bioactives like caffeine that we consume. And then, based on the scientific evidence, it can tell us whether we need a little bit more of something or a little bit less of something. So again, it's not meant to be perfectly prescriptive and to say, oh, you need 454 milligrams of this micronutrient. That's not what the science shows. It just shows you need to be towards the upper end of the recommendations for this. And for something else, you can be towards the lower end. So that's when I think of really some of the micronutrients. What it can also tell you is your risk of certain intolerances. And again, it's not diagnostic, definitely not related to food allergies at all. In fact, we've been asked if we can provide genetic tests for food allergies. There are genes that increase your risk of a food allergy, but the only way to know for sure is by an IgE blood test that tells you for sure that you have a food allergy. So what's the point in telling someone, "Oh, you have a twofold higher risk of, having an allergy to soy?" Well, just test for it, right? You don't want to avoid it if you're not allergic, right? Because that can actually, promote an allergy if you're avoiding certain things, especially at a young age. So, cannot tell you anything about food allergies, but it can tell you about food sensitivities and the risk of food sensitivities and intolerances. So, your next step is, well, all right, then I'll try it. I'll see what happens if I limit my histamine intake in my diet. Do some of those symptoms go away? If it's something like gluten and you have the high genetic risk for celiac disease, then go get a blood test for those antibodies that will diagnose it definitively. So in some cases, it can result in immediate action. In others, it can say, okay, now you need to do other tests to confirm or to, uh, you know, refute whatever was possibly a risk.
It's like shining a flashlight or a spotlight over it. Like, hey, pay attention over here and pay attention over here and think twice about this and think twice about that. Right. And it doesn't mean, like you said before, like, it
Exactly.
doesn't mean that you should just drink coffee as your only beverage if you're not showing to have a genetic predisposition to coffee issues. But so we want to be careful just in case somebody goes off the deep end over there. But
Yeah.
but it's like a spotlight on where you should pay attention and what can help solve different problems. Like, the body is amazing. And the way that we interact with our environment, with food, with all these different things, for each of us, there are differences. And so it gives us an idea of where to go. I know
Absolutely.
there's I know that there's a lot of hype in the genetic space, or a lot of concern in the genetic space based on some of the things that have happened in over time with some companies selling data and privacy and all of that. What do you want people to understand about privacy and DNA data when it comes to nutrition related genetic testing, or the testing that Nutrigenomix does?
Mhm. Yeah, that's a great, excellent point, and I think it applies to any kind of consumer genetic test, and the kind of the privacy laws and the how the data is handled and safeguarded differs from company to company. there are some, kind of standard safeguards that are in place, but those are very minimal, right? I mean, there's legislation in the U.S. that, laws rather, sorry, legislation here in Canada that prevent companies and employers from discriminating against people based on their genetic results. So, and that's comforting because a lot of people are concerned, like, oh, well, I don't want to get a genetic test. What happens if my insurance company finds out? What happens to my employer? And that information cannot be used against you. Um, However, there are some companies, as you mentioned, that have done research on individuals' DNA, or they've sold it to big pharma companies. We do not do that. We have probably the most stringent standards of privacy, confidentiality. Um, the sample that comes to our lab, it just has a barcode. You're probably familiar with this. We have some of our practitioners the new practitioners who say, "Oh, where's the requisition? Where do I write my patient's name, age, date of birth, and all this identifying information?" We're like, we don't need it, right? You know which client that barcode belongs to because you entered it into your account with their first name, and our lab just gets that barcode. Um, but the other thing is the information that we test for, the genes, even if I was an insurance company, I wouldn't know what to do with that information, right? What's the point in finding out that someone is a slow metabolizer of caffeine without knowing if they even drink coffee? That alone, that information is useless, right? Or if someone has the gene for salt sensitive hypertension, well, it would I couldn't be able to justify increasing their premiums because it doesn't mean they have a higher risk of hypertension if I don't know how much sodium they're consuming. So even the information that's contained, first of all, there's no way of identifying it outside, right? Because we separate any kind of identifying information from the actual results. But even so, the information that we test for, it's all empowering. There's nothing that's damning. I like to say that there's really no such thing as a bad result, right? And so it really depends on whatever your result is, that's the action that you can take.
Yeah, that's perfect. And thank you again for like having those high standards of integrity. Where do you think personalized nutrition is going to head, say, over the next 5 to 10 years?
Well, I think the science is still continuing to grow. And when I look to see where we were 5 years ago, and if I would have predicted where we are now, yeah, it wouldn't have been that far off. I would have said, you know what, we're going to have more evidence for more markers that affect more aspects of the diet related to more different outcomes. Now, there's a lot of, those who like looking into the crystal ball and saying, oh, well, AI is going to take over. And you hear a lot about this, and there's a lot of companies that can bounce around that buzzword, saying, "Oh, our technology is grounded in AI." Well, what are you using AI for, right? You can't do the research on it. So, in terms of making these discoveries, you still need a human to come up with these hypotheses and test it and do the statistical analyses. Now, AI can help us do these things much more quickly, but at the same time, we still have to make sense of that data. And even if AI does help us to make sense of it, or even if it can take over and do that, you are still left with recommendations, right? We still need to eat every day, right? And eating is based on the science. So whether AI contributed to developing that science or not, I can see where AI can help in terms of creating meal plans, right? And this is something that has been revolutionizing the field. So a lot of those meal planning softwares now are incorporating AI. Right? There's no point in telling someone, oh, here's this recipe that has broccoli when you can't stand the taste of broccoli, or it has, pork when clearly, for religious reasons or other reasons, you don't eat pork. And so that's where I think there could be benefits of that technology. But in terms of precision nutrition, um, it's really, I think it's the recommendations are going to become simpler, not more complex. Because some people say, oh, well, you have to integrate all these omics technologies and you got to include the microbiome. No, I've never seen an example where that adds more information. Um, Whether that's 10 or 20 years down the road, that's another story, but certainly not in the next, I'd say, 5 to 10 years. We're just going to get more of this kind of information. The challenge will be, how do we communicate it? How do we chunk up that information to make it easily digestible by the end user? Because behavior change is the ultimate outcome. That's what we're trying to get people to change. And we've actually shown, using randomized controlled clinical trials, that giving people the right kind of genetic information does help motivate them to change their eating habits, which is, as you know, often one of the most challenging things to do.
Yeah, I can vouch for that. I see it in my practice all the time. Someone gets their nutrigenomics test and they're like, "Oh, all right, Dr. Z, I got to listen a little better." But it gives them that impetus, like it's now real. It's now real to them, like they see
Mhm.
it like, "Oh, okay, that's in my genetics. I need to start to pay attention to that." So it's really helpful. And you guys do a really phenomenal job about making that information understandable, in your report so that people can make practical changes. So putting it into real English is important, and you guys do a phenomenal job, like I said. So
Thank you.
before we wrap up here, if you could leave our listeners with one, practical takeaway today, what would it be?
I guess get your nutrigenomics report. I mean, that would be a simple one. And a lot of people do it just out of curiosity, right? I mean, but we do, when speaking to our practitioners, because we don't sell direct to consumer, but through our practitioners, and there's a network of over 13,000 practitioners in like 95 countries. They tell us that oftentimes it's patients that are struggling with some kind of health issue that, conventional medicine hasn't been able to help them with. And we actually do hear many cases where this has helped. And in some cases, we've heard from practitioners say, "Oh, well, I had a client who came to me for this particular issue, and once they did the nutrigenomics report and followed the advice, it didn't particularly fix that issue, but it got rid of something else that was also bothering them that they didn't come to them to see them primarily for." So, like I said, we're trying to get people to eat healthier. And this is, as you say, good analogy, and I've used this before, shining a light on what aspects of the diet they need to focus on. So you don't have to have an underlying health condition. You don't have to have a family history. If you just want to know how your body metabolizes different nutrients, and what end of the spectrum you should be for various dietary factors, get a test and see how that resonates with you.
Yeah, that's super helpful. And can you just share how people can find nutrigenomics? And I'll after you're done with that, I'll let people know where they can order the test because we have access to it, and we'll give them a coupon code as well. So
Sure. Yeah, so through your clinic and through many other clinics. Again, if someone in a different country is listening here, Nutrigenomics with an X at the end, um, and on our website we do have a contact us page for practitioners who want to learn more and become providers themselves, and for consumers who want to get the test, we can connect them to a practitioner in their region so that they can get access to the service.
yeah. And anybody who's listening, you can we'll put it in the show notes as well. So all the links to the Nutrigenomics main site. But you can also go to go.southbaywellness.com/genetics test. And then we'll have a coupon code in there for you as well. We'll use the coupon code True Wellness for that test. So you can go ahead and order the test there, get the information. We do also do a review of findings with you so you can get that personalized stuff. So thank you so much for being here with us today, and again shining a light on this important topic, and helping people to really come to understand a little bit more about their body so they can begin to make the changes necessary to achieve the health and longevity that they desire for the long term. So thank you again for being here today.
Thank you for having me. It's been fun.
This is Dr. Z reminding you to tune into your body, connect with what matters, and embrace your journey to true wellness. If you enjoyed today's episode, be sure to subscribe, leave a review, and share this with someone who's ready to redefine their health. Be sure to grab a copy of the True Wellness Checklist right in the show notes. Let's keep redefining wellness and empowering change together. See you for the next episode.